Welcome in my ASVAB party, people. My name's Coach Anderson, if you haven't met me before, and I'm happy to present to you our math knowledge practice test. Everybody knows how much it sucks to go ahead and pass a practice test, but then fail the real deal. You know, we don't want to be in that position, and so this video is going to help you build the confidence you need without all of that wishy-washy, hoping, and false sense of confidence. I'm going to show you exactly how to get each and every one of these problems correct, and if you're in my program, I'll show you exactly where to go to get additional practice. But for those of you who are studying for free, don't worry, I got your back. We have a free ASVAB class once a week, and we have an additional set of practice tests for you for arithmetic reasoning, math knowledge, word knowledge, and paragraph comprehension on our website, and you can just check that link out in the description of this video. Again, all of it's free. I'm here to help you out and get the job that you deserve, so let's go ahead and do things the right way. Don't memorize questions. Let's try every single one of these questions out coming up next. And then you can skip over, you can see over here, you can hover over the play button, and you'll see the exact time that the questions are gonna be solved at. So you can skip ahead, get the information you need, learn, and keep moving forward. Again, my name's Coach Anderson, and as always, thank you for going ahead and joining us. If you like this at the end, leave a like, subscribe, and comment. That way we can keep helping people just like you. Again, my party people, let's keep having fun. Let's raise our scores so we can get that job we deserve. If you have any questions, just let me know. I got your back, and let's ace the ASVAB. All right, my party people, number one, here we go. We're trying to simplify the expression, and we have what looks to be order of operations, and that is correct. So this first question, if you are in the program, this belongs to Unit 1. And again, that's going to be order of operations. So the way that we're going to get this done is we're going to go ahead and understand how PEMDAS works. So we have P, E, and then MD, and then AS. The reason I write the M and D together is because multiplication and division, it's whichever comes first, okay? They're the same operation. Multiplying, you're just scaling up. Dividing, you're scaling down. Same thing with addition, subtraction. It's whichever one comes first. Because addition, you're just moving a number to the right on a number line. Subtraction, you're moving it to the left. And so therefore, again, it's just movement. They're the same operation. They just tell you which direction to go in. Same thing up here. So we look over here and we see that we have addition, division, multiplication, and subtraction. So no matter what, this is what you should be taking care of first. And the first thing is right there. It's going to be the division. So again, although multiplication comes right there, it's whichever comes first. So write that down if you need to. So booyah, we're good. We're going to be doing the 12 divided by 3 first. So we'll end up having 8 plus 12 divided by 3, which is 4. Write everything else out, and we continue on knowing that we're going to multiply now right here. Once we're done multiplying, that's going to be another 8. So we'll have 8 plus 8 minus 1, which is 16 minus 1, giving us a final answer of 15. And that's why B is the correct answer for question number 1. All right, let's get into number 2 here. So we have an equation. So for, again, those of you in the program, that's going to be Unit 3 in math knowledge. That's going to be solving equations. So let's zoom on in again and let's get this done. We have 0.2x plus 4 equals 3.4. So remember that decimals, they're just numbers. We don't want to get in our own way by, looking at this and thinking that we can't do it. We know what we're supposed to do, and if we're just not adept at dealing with decimals, take a note of that so you can continue working on it moving forward. So what do we know about equations? We know that the goal is to get x by itself. So what I need to do to get the x by itself is going to be to get rid of that 4 and get rid of that 0.2. So the first thing I'll do, I see that we're adding 4, so I'll subtract 4 from both sides. Once I do that, we see that we're going to cancel out on that left side, which is exactly what we wanted to do. And now we have 0.2x equals, and on the right side, we'll have negative 0.6. Remember, subtraction, we're just taking the difference. What's the difference between 3.4 and 4? It'll be 0.6, but the problem is it'll be negative because, again, you're taking away more than what you have. So the last step here will be to divide both sides by that 0.2. And so this is where, if you are not entirely comfortable working with those fractions or decimals, then that'll really show here, and that's okay. But here's the little trick. The little trick is that we can simply go ahead and, if we don't want to divide by a decimal, which we shouldn't, we can move that decimal over to the right one time. But remember, whatever you do to the bottom, you do to the top. So we'll do the same thing, booyah, right up there, which will give us x cancels out with the 0.2, x equals, and it's going to be negative 6 over 2. My party people, I think that's a lot easier to deal with, right? I think so too. So with that said, negative 6 divided by 2, 6 divided by 2 is 3. So that'll be negative 3. And so therefore, the answer to this next question, boom, B, negative 3. And don't forget, this is Unit 3, Solving Equations in Math Knowledge in your course. Up next, we have question number 3 coming up, and we are trying to solve the inequalities. So when it comes to solving inequalities, to find that in the program, that's going to be unit number 4. Solving inequalities is in Math Knowledge, Unit 4, so make sure to check that out if you want to do more of these types of problems. So here we have negative 4x plus 7 is greater than negative 1. So how do we take care of business here? Well, what we're going to do is treat it like an equation. The only rule when it comes to inequalities is that whenever you multiply or divide both sides by a negative, again, whenever you multiply or divide both sides by a negative, that's when this sign, this symbol, flips. So let's treat it like an equation. I got to get x by itself. I got that plus 7, that negative 4 attached. So let's take care of this first. We'll subtract 7 from both sides. Nice and easy. Once we do that, cancels on the left, giving us negative 4x is greater than negative 8. And now from here, we'll go ahead and divide both sides by that negative 4 right there. Booyah. And we'll go ahead and cancel this out on the left side. And then we'll have x, but what just happened? Yeah, we just divided by a negative on both sides. So that greater than symbol is actually going to turn into the less than symbol. Because again, we divided both sides by a negative. So now that we have that going on, we'll take a look at the right side here. Negative divided by a negative, that's going to be a positive. 8 divided by 4, that will be 2. So there's our answer. X is less than 2. Booyah, right here. That's answer choice D, my math party people. Moving forward here to question number 4, my party people. So question number 4, if you're in the Math Knowledge course in the program, you can find this in Unit 6. So this is Unit number 6, and this has everything to do with distributing polynomials and combining like terms. So if you want to learn more on that, get a lot of practice with step-by-step solutions, again, you know where to go in the program. So here we go. We want to multiply the following binomials. We have 3x plus 5. Multiplied by 2x minus 7. Sounds good. So let's go ahead here and set this up right along the side. So 3x plus 5, 2x minus 7. And let me go ahead and remind you that, yeah, sure, if you knew FOIL, F-O-I-L, yeah, first, outside, inside, last, yeah, that works if you remember it that way. But just remember the simple rule. The simple rule is that everything from one parentheses multiplies with everything from the other. That's how distribution works. Everything from one parentheses multiplies with everything from the other, and I can color code it to show you how easy it actually is. So look at this. Number one, I'm going to go ahead and make sure that this 3x right over here multiplies with both the 2x and the negative 7. So first we're going to take care of that 3x, just like I said. So in blue, 3x multiplied by 2x will give us 6x squared. Remember, x times x is x squared. Anything multiplied by itself is that number squared. So we have the blue down, nice and easy. Now we'll go to the red. So the second connection here, 3x multiplied by negative 7. A positive times a negative, my party people, that'll be negative. 3 times 7 is 21, and then we keep the x. Next up, well, now we're done with the 3x. Now we have to take care of distributing the 5. So we'll go ahead and distribute the 5 to the 2x, and we'll also distribute the 5 to the negative 7. And that's it. That's really all you have to worry about. Everything from one parentheses multiplies with everything from the other. And that's it. So in green, we're going to have 5 multiplied by 2x, which is going to be a positive 10x. And then from there, we have 5 multiplied by negative 7, which is going to give us negative 35. Sweet, we're good. Now that we're here, the next step is going to be to combine like terms. So we see that we have no other x squared terms, nothing else there. We have 2x terms, and then we just have a regular old number. So this right here is what we're going to combine like terms on. Nice and easy. So we'll go ahead and say, let's use red. So we'll combine like terms right here. And so what we have now, it'll be 6x squared negative 21x plus 10x. You can basically say negative 21 plus 10, which would be negative 11x. And then we bring down that minus 35, and we're done. Booyah. We take a look at our answer choices. 6x squared minus 11x minus 35. That's going to be answer choice B. Booyah, my party people. So again, that's going to be polynomial distribution and combining like terms. Let's go ahead and keep moving. All right, and here we have question number 5. So my party people in the program, this is math knowledge, unit number 6. Again, just like question number 4, question number 5 is also unit 6 in math knowledge, because here we're just going to be combining like terms. So we check things out. We just need to make sure we find terms that have the same variable and the same exponent. Again, like terms, let's write this down over here. Like terms, we have the same variables right there, and we have the same exponents. Booyah, right over there. So that's what we need to get this going. So let's check things out. We see that we have, let's start with the highest exponent, so x squared. How many other x squared terms do we have? Well, I see that we have 3.7x squared, and then we have a positive 2.4x squared. So if we combine those, essentially what we're doing, my party people, is we're doing 2.4 plus 3.7. You can think about it as 24 plus 37, bring that decimal back if you want to, and that would end up being 6.1. So what we have first, it'll be 6.1x squared. Remember, when you combine like terms, you keep that variable and exponent the same. You just combine those numbers in front, which are called coefficients. So next up, my party people, here we go. Let's look at those x terms. I'm going to highlight those in red here. We have 4.2x and a negative 1.5x. So we bring those together, and essentially what that turns into is it'll be 4.2 minus 1.5. And again, we keep the variable, the x, the same. 4.2 minus 1.5 will give us 2.7, positive still. And then lastly, we see that that negative 0.8 is still there, so we'll just say minus 0.8, and we're good. There's our final answer. We take a look at the choices that were given, and we see that that's gonna be B right there. Let's answer choice B, and we are set. That's number 5, my party people. Let's keep moving forward. And moving forward to number 6 here, my party people, this question here is going to be found in Math Knowledge unit number 9. So for question 6 again, unit number 9, and unit number 9 is going to be slopes and lines. So let's go ahead and understand the question first. The question is, what is the y-coordinate of the third point? Okay, let's see what we have here. So we see that we're dealing with a line, and it's passing through the points 2, 5, and 6, 13, and it's extended, and we have a third point with x being 9. What's the y for that third point? So essentially, my party people, here's how we want to think about it. We have the point 2, 5. We have the other point 6, 13. And then we're looking for that third point. The x coordinate is 9, but we don't know what that y coordinate is. So that's our job right now. We have to go ahead and figure out what that third coordinate's y value is. How do we do that? Well, the great thing is they kind of give us a huge hint saying that this is a line right there. Booyah. Why is that super helpful? Well, because lines have a constant slope. Once we know what the slope is, we know how much we're supposed to go up every time we jump up 1 by x. That's what slope means. It tells you every time you go up by 1 on the x, how far up or down are you supposed to go? And it's the same throughout the entire thing. So here's what I'm going to do. I'm going to find the slope between these 2 points, and then I'm going to keep adding it up until I get to the 9. So here we go. What's our slope formula again? It's going to be slope equals y2 minus y1. If you're getting PTSD right now, I understand. x2 minus x1. So here we are. And really all this means, just to help you out, my party people, when you're calculating slope, notice that we have 2's up first and then 1's next. All that means, I'm not trying to confuse you, it just means we need to subtract in the same order. So what does that look like? Well, my party people, easy. We can say this over here is our x2, y2. This is our x1, y1. And so, booyah, this right here will make sure to plug in the 13 up top and then the 6 on the bottom. They both need to come first. We can't switch the order from the top and the bottom. Not gonna work. So let's go ahead, write out our slope right over here, nice and easy. And we'll see that we have 13 first up top and then the 6 on the bottom. Next, what are we supposed to subtract? Well, we're supposed to subtract the first coordinate. So on top would be the y, and on the bottom would be the x. Just make sure to do it in the same order. Again, what I mean by that is, this could be x2, y2, this could be x1, y1. Just make sure to be consistent and you'll still get the same answer no matter what. So what we have now is going to be 5 up top, 2 on the bottom, and what we get from that is 13 minus 5, that's going to be 8. 6 minus 2 is going to be 4. 8 divided by 4 is 2. Now, that's not our answer. This is the slope. That is just going to be the slope, my party people. How useful is this? How is this supposed to help us out? Well, like I said, this is the cool thing about slope. What I know now is that every time I go up 1 for the x, we're going to go up by 2 on the y. That's what slope means. Every time you move, you're moving by 2. So here we have 2, 5. Watch this. This is pretty cool. I'm going to go up to 3, which means I'm going to go up by 2 over here. So that's 7. Okay, what about 4? Go up by 2 again. That'll be 9. What about 5? Go up by 2 again. That'll be 11. Okay, what about 6? Go up by 2 again. That's 13. Look at that. So we proved it. We found the right slope, which means we can continue applying it from 6 to get to 9. So we know that we can go, and I'm showing you the really rudimentary way. If you know your mental math, you know that there's a much quicker way to do this. But we have 7, then 15, 8, then 17, 9, then 19. Booyah, there it is. We just kept counting up by 2 for every x, and there we are. The answer here would be answer choice C. So my party people, that's just one of the different ways we can do this one. But again, if you want to practice more here, again, Unit 9, Math Knowledge. Let's get on to the next one. All right, here we are, question number 7. Question number 7 here, we're talking about a right triangle. And so exactly where you're gonna find more practice like this one, this is gonna be a Pythagorean theorem problem, and this is gonna be found in your math knowledge course, unit number 10. That's where pure geometry is gonna be found. So you're talking about complementary and supplementary angles, you're talking about angles within shapes, you're talking about relationships like the Pythagorean theorem, all that will be in there. Let's get to this one here. So the question is, what is the length of the other leg? Okay, let's highlight that, nice and easy. Length of the other leg. So leg equals blank, and it looks like we're saying inches, so I'll just say inches. Nice and easy. Next up, what do we have? Well, we are clearly told that we have a right triangle. The moment you hear that you have a right triangle, I really want you to think about the Pythagorean theorem. Like, chances are you're probably going to be dealing with it. Remember that the Pythagorean theorem is a squared plus b squared equals c squared, where c is always that longer side across from that right angle. That's always where c is going to be. And then a and b can be whichever of the two remaining sides. It doesn't matter. A and b can be whichever one of these. It's that c is always the longest side across from that right angle. So how are we going to use this to our advantage? We see that one leg is 8 inches and the hypotenuse is 17 inches. So we can write that out, and we can say, again, one leg we'll say is 8 inches, and the other one, the hypotenuse, they specifically say hypotenuse, so that's how you know you're dealing with this, will be 17. All right, how do we find that other leg? How do we find A? Well, right here. We're going to use that formula, and we're going to put in that work nice and easy. So here, we'll say a squared plus b squared. 8 is b, so 8 squared equals c squared, which is 17 squared. Okay, looks like we got a little bit of work to do, but that's totally fine. Let's get in here. 8 squared, that's going to be 64, because squared means multiply that number by itself. 8 times 8, that's 64. 17 squared, what's that going to be? Well, if you didn't know, don't worry. Just go ahead and multiply it out, and you're good. 7 times 7, 49. 1 times 7 is 7, plus the 4 is 11. Plug a 0 in. 7 times 1, 1 times 1. And then we are going to have 9, 8, and 2. So 289. So what do we do next to solve here? The next step is going to be try to get that a by itself. So the first thing that we'll do will be subtract 64 from both sides. Once we do that, we're going to get a squared equals, because again, we have that cancellation here. And on the right side, we'll have 225. Now, is 225 the answer? No. Remember that we're trying to get the value of a, not a squared. We're just trying to get a. So what does this mean? Well, what this means is we're trying to figure out what number that can multiply by itself and give us 225. So for example, imagine if this was, instead of 225, imagine that was 9. If that was 9, a squared equals 9, well, the answer is 3, because 3 times 3 would be 9. Here, we're trying to figure out a much bigger case of the same issue, and that's okay. What times itself can give us 225? That will be 15. 15 squared, or 15 times 15, that is 225. 5 times 5 is 25. 1 times 5 is 5, plus the 2 is 7. And then we have 5 times 1, 1 times 1, and that right there is 225. So there, we know for a fact that A is indeed 15. And so there we go, we found that leg. Answer is C. Ooh, yeah, my party people. And there we are with question number 7. All right, I love this question. I love number 8 because we are dealing with a system of equations. So for those of you who want to work on system of equations, again, in that math knowledge course in your account, that's going to be right over here, math knowledge, unit number 5. So you can get plenty of practice with this, with those step-by-step solutions, guided practice videos and lessons. All of that will be there for you. So let's check it out here. How do we do this? How do we solve a system of equations? They're scary. Well, it's actually going to be pretty straightforward. The goal here, let me write this out first. The overall goal, my party people, is really going to be, hey, can we figure out what at least one of these values is, because then we can get the other. If we have two variables in the same equation, we can't just solve this by itself, and we can't solve this by itself. The goal actually is going to be combining these together in some way, shape, or form to figure out what one of the values is. How do I do that though? Well, let's take a look over here. Let's just make a little more room for ourselves. Notice that if I were to magically be able to eliminate the x, I can work with the y. Or if I magically eliminate the y, I could just work with the x. And the way that we can do that is this. I'm going to use this concept of elimination. Again, this is system of equations right there. That's the name of the topic. And we are going to use elimination. Here's how that works. The way that it works is I'll proceed to say, well, I am going to try to get rid of the y. And if I combine these, if I add these together, well, 3 minus 2, that's just going to be 1y. That doesn't eliminate it. But what I can do, if these were both 6, like a positive 6y and a negative 6y, if I add those together, well, opposites cancel out. So that's what I'm going to take advantage of. And here's how I'll do it. I'll go ahead and say, hey, this bottom one, if I can get this to 6, that's perfect. And I know 2 times 3 is 6. Well, what about this top one? Well, I know that 3 times 2 is 6. So what I've just done is I've set myself up to multiply the entire equation. So both sides of the equation by 2, both sides by 3. Look at the beauty that happens next. So 2 times 4x is 8x. 2 times 3y is positive 6y. 2 times 23 is 46. Okay, nice and easy. Still going strong. Up next on the blue side of things, we have 3 times 5x. So that'll be 15x. 3 times negative 2y, so negative 6y. 3 times 8, which is 24. Okay, take a look, my party people. What just happened? Again, if I add these together, look at what happens. We have 8x plus 15x. That would be 23x. But then, interestingly, over here, what happens? They cancel out. We have a positive 6y and a negative 6y. Add opposites, and they will cancel out. And then when we look at the right side, we see that we have 46 plus 24. What will that give us? Well, 46 plus 24, making sure I didn't miss anything there. Cool. So 46 plus 24, that would end up being 70. All right, perfect. I think we are good. And what I mean by good is I think we can now go ahead and solve for x by dividing both sides by 23. Once we do that, boom, we're done. Cancels out on the left side, and we have x equals 70 over 23. So that's x. If we wanted to find y, all we have to do is take this value of x and plug it back into here or plug it back into there. Either one is fine, and we'll be able to solve. But the great thing is, in this question, we don't need to. Why don't we need to? Well, because 70 over 23, which of these answers has 70 over 23 for x? Just C. Just this one right there. And so we're set. We know what the answer is. We don't need to do any more work, and we can move forward knowing that we're good. All right, question number 9. So question number 9, again, for those of you in the program, we are going to log in and go to unit number 1. This is an order of operations problem here. So let's go ahead and dive on in. The only difference here is that we have some decimals that may kind of freak us out, and that's okay. But we're going to go ahead and just tackle the operations. Remember, PEMDAS. Right there, remember. It's multiplication, division, whichever comes first, addition, subtraction, whichever comes first. So I notice here that we have division and multiplication. So what I'll do is I'll just say, hey, which comes first? The division. So this is what I'll do first. So that's going to give me 7.5 plus 12 divided by 3, which is 4. And then bring that times 4 right there. So now we'll do the multiplication. 4 times 4, that'll end up being 16. And then 7.5 plus 16, just think about it like this. 7 plus 16, that's 23. add the 0.5, and there we go. So evaluating this expression, order of operations, that's going to give us B, 23.5 for question number 9. All right, let's keep the party going here. Question number 10. Here we go. So question number 10, what are we looking for? We're looking for the value of x. Okay, that doesn't tell me much, but at least I know that there's a variable that I'm looking for the answer to, right? All right, so what is the value of x? Let's see what the deal with x is. We have angles 1 and 2 are complementary angles. The measure of angle 1 is this many degrees, and the measure of angle 2 is that many degrees. What's x? Okay, so let's try to figure this out. But it's actually going to be pretty straightforward as long as you know the terminology. So we know that angle 1, they describe it as, and I'm going to highlight it over here for you. We are describing angle 1 as 5x plus 20 degrees. So that's going to be equal to 5x plus 20. Okay. Then we have angle number 2. And what are we told about angle number 2? Well, the measure of angle 2 is 3x plus 40 degrees. So I'll write that out as well. 3x plus 40 degrees. Okay. Now, what do I do with this information? Like I said, the terminology really matters here, because what we have over here, let me highlight this in purple. We have that angles 1 and 2 are complementary angles. What does that mean? Well, complementary angles add up to 90 degrees. That's what complementary means. And if you accidentally said 180, what you're actually thinking of is 180 supplementary angles. Supplementary are 180, complementary 90. So we know that these two angles, if we add them together, it's going to be 90. And we now just made our equation. We can say confidently that 5x plus 20 plus 3x plus 40, that's going to equal 90. And that is what I'm going to focus my attention on now. I'm going to focus my attention on solving this equation. And I know immediately on this side of things, I can combine like terms 5x and 3x. So let's highlight those. And so that'll be 8x. And then we can highlight over here the plus 20, the plus 40. That will give us plus 60. And then we have that equaling 90. So now it's just a regular old equation. We can tackle this like normal and we're good. So here we'll have minus 60 on both sides. Booyah. And so it's going to cancel out on the left, my party people. And that'll give us 8x equals 30. And then the last thing we need to do is divide both sides by 8 and we're done. Don't worry if you're afraid of, finding out that decimal answer. Just know that that's a point that we need to work on. Notice that we have two potential decimal answers. And I know that 8 does not go into 30 very cleanly. So I'll go ahead and show the long division here. 8 going into 30. 8 goes into 30 3 times because that's 24. 8 times 3. Get that 6 remaining. And we'll drop that 0 here for the decimal. So 8 goes into 60 how many times? That would be 7 times. Subtract that 56 because 8 times 7 is 56. And then we'll just continue going here. And we see that we have 8 going into 40. That'll be a clean 5 times. And we're done. Our answer here for x is 3.75. And there we go. Our answer is A. All right, let's keep the party going here, my party people. So this is question number 11. If you want to know where to find this in the Math Knowledge course that's part of your program, we're going to go ahead and go to Math Knowledge unit number. That's going to be unit number 6. So this is going to be polynomial distribution and combining like terms. So this is a great opportunity to really show you how important it is to know your rules and not just, only know it one way. And what I'm referring to specifically is FOIL, F-O-I-L. Who remembers that? I talked about it earlier in this video, and you probably heard it before. Most people will look at this and will say, FOIL, first, outside, inside, last. But the problem with that is, look, first, outside, inside, last. What are we doing with this negative 4x? Nothing happened to it. So that's why I don't like teaching FOIL only, because it's a specific rule. It's like only learning about squares and never learning about rectangles. That's really what that means. So here's the right way to kind of think about it. Remember, distribution. For those of you in my program, you know I say this a million times every time we do this class. We are making sure that everything from one parentheses multiplies with everything from the other. That's what that means. So let me show you nice and easily how to get this done. So I'm going to make sure, first and foremost, that this 2x right here multiplies with the x squared, multiplies with the negative 4x, and multiplies with that positive 5. Again, everything from one parentheses multiplies with everything from the other. So we have 2x multiplied by x squared. That's going to end up being 2x cubed. Law of exponents says x times x squared. We add those exponents. There's a 2 here. There's an imaginary 1 right there. That's going to be 3. Next up, we are going to take care of the 2x multiplied by negative 4x. That's going to be negative 8x squared. Next, we have 2x multiplied by 5. 2 times 5 is 10, so that will be 10x. So we're not done though. We are not done. That's just the first part, because now we have to take care of distributing the 3. The 3 needs to go to the x squared, the negative 4x, and the 5. Again, it's a simple rule. For distribution, make sure that everything from one parentheses multiplies with everything from the other, and you're good. You're super fine from there moving forward. So here, we'll take care of it. So 3 times x squared will be 3x squared. Then we have 3 times negative 4x, which will be negative 12x. And then we have 3 times 5, which is going to be 15. Sweet. So now our job is going to be to combine like terms. So we see that the 2x cubed is the only one of its kind. We have squared, squared, but we don't have cubed. So that's fine. That's perfect. We just rewrite that and keep moving forward. Next, I notice that we have negative 8x squared, positive 3x squared. Those can be combined because they both are x squared terms. Negative 8 plus 3 will be negative 5. So negative 5x squared. Next up, for combining like terms, I notice that we have positive 10x minus 12x. So what will that be? Well, a positive 10 minus 12 will be negative 2. So negative 2x. Keep that variable. And then lastly, the plus 15, that's just sitting there. So we just write plus 15. And there we go, my party people. What's our answer going to be? Well, we have 2x cubed. They all say that. Negative 5x squared. So only this one and this one. Negative 2x. That's only this one. And then the plus 15. Therefore, my answer is D. And there it is. Again, we can go calm, cool, and collected through this, and we can have a good time. All right, number 12, my party people. Number 12. So if you want to practice greatest common factor, least common multiple, and all of those little rules that really matter for algebra, you're going to be able to find that in your math knowledge course. That's going to be unit number 2, my party people. Unit number 2. So here we go. Let's go ahead and get it done. What is the greatest common factor of 135 and 180? Okay, so here's what we can do. One main way is using a factor tree. We can definitely do that, and we can definitely do that until you realize how to do this mentally. But what I noticed is that, well, if you go to the gym a lot and you load 45-pound plates on the bench or the squat rack or whatever you do, you might notice that 135 plus another 45 is 180. You might also know that 45 times 3 is 135. 45 times 4, that's 180. So you might instantly be able to see this as the answer being C, 45, but in case you didn't know that automatically, no worries at all. I can go ahead and show you how you'll get this done using a factor tree. So first thing I'm going to do is I'm going to break down both numbers into their prime factors. Watch this. I'm going to say 180. I'm going to say that that's going to be 2 times 90. 90, we can write that as, we can go ahead and say 3 times 30. Then 30 could be written as 3 times 10, and then 10 could be written as 2 times 5. So what are my factors here? we have, I'm going to highlight these. We have 2, 3 times 3 times 2 times 5. Keep that in mind for a moment. We'll come back to this in a second. Let's now look at 135. Let's break that down. Well, I know because it ends in a 5, it's divisible by 5. So I'm going to say 5 times what? Well, I can do some long division real quick, going into 135. And we see that 5 into 13 is twice. Then we have 5 into 35, and that's 7. And that's a clean 7. So that'll be 5 times 27. 27 is going to be 3 times 9, and 9 is the same as 3 times 3. So there are my factors here. We have 5, 3, 3, and 3. So where do we go from here? Where we go from here is we're going to circle all of the ones that they have in common. So I'm going to say right over here, my party people, we have a 5. Okay, great. So let's write that down. What else do we have? We have ourselves a 3. So times 3. And then we have another 3 that we can use. So times 3 again. And boom, nothing else. Because we have another 3 here, but we don't have another 3 to circle. We have 2's here, but we don't have any 2's to work with here. Again, it's what we have in common. So 5 times 3 times 3 will be the answer. 5 times 3 times 3. So 3 times 3, that's 9. 5 times 9 is 45. So again, still a very doable problem. There's our answer right there. But if you know your mental math, you'll definitely be able to see this much faster than you would have without the practice. Let's go ahead and keep moving forward, my party people. You got this. All right, looking at question number 13. So this is a familiar one. This is going to fall right on our math knowledge unit number 9, slopes and lines. That's where you'll find this question, question number 13 in your program. So let's go ahead and look at the problem here. It says, what is the slope of the line that passes through the points -3 and 5 and 4, -2? So let's write out those coordinates first. That can feel a little confusing, but I know when you did this on the website, that would have been in line. So I apologize for that little formatting error, but it's still a -3. So we have -3, 5, and then 4, -2. So just like I said earlier, I'm going to be consistent. We need to make sure, absolutely need to make sure, that we are consistent in applying the formula. So slope equals, again, y2 minus y1 over x2 minus x1. Again, this is all fancy speak for just saying, hey, subtract the y's up top, subtract the x's on the bottom. Just be consistent. You know, if you choose the second y to go here, then this second x is from that same coordinate. Or if I chose 5 right here for the y, well, then the -3 would be first, then here. It just matters about the order. And to prove it to you, watch this. I'm going to go ahead and just say this is my y2 and x2. So it would be x2 first and then y2 second. So let's write that in. Just watch. Very straightforward. We have 5 for the y2. We have -3 for the x2. Write out those subtractions. Write those out. Don't forget those because you don't want to get confused, especially with a negative coming up. And then this part over here will be our x1 and y1. Again, just because there's already a negative here does not mean you'll ignore that negative there. No, no, no. Don't be reckless. Be careful. Be smart. So y1, that's -2. So notice we have a double negative. We'll take care of that in a moment. And then we have the 4. So let's zoom on in over here and let's take care of business. So what's going to happen? Well, a double negative that's going to cancel to make a positive. So we have this being equal to 5 plus 2. And then we have -3 minus 4. If we're already negative and going more negative, that'll be -7. So now what we have is 5 plus 2 being 7 up top, -7 in the denominator. 7 divided by -7, what's that going to be? Yeah, that's going to be -1. And there's our slope. And in case you wanted to double check your work, well, guess what? If we're going from -3 all the way to +4, -1 means this is going to go down as we continue moving forward with the x. Is 5 going down? Yes, it does go down. So that's, again, another way to just triple check your work. Booyah, my party people. That's question number 13. And for question number 14, my party people, this one is going to be found in, again, math knowledge, unit number 9. So this is a slope question where we're being asked to find the slope of the line that passes through the points 3.5, -2, and 7, 6. So let's go ahead and write those coordinates out a little more clearly. We have 3.5, -2, and then 7, 6. Okay, so when we get this done, my party people, remember, all we're trying to do is just be consistent, set up the formula correctly, and do the math correctly. The formula, don't worry if it's a decimal. It doesn't matter. Decimals are just numbers. So our slope formula is going to be, again, y2 minus y1 over x2 minus x1. So again, all we're saying here is the y is being subtracted divided by the x is being subtracted. Just make sure to subtract in the same order. So if this is the y2 that you choose, this has to be the x2. Similarly, if this is the y2 that you choose, well then this has to be x2. So whatever you choose the 2 from, it's the same 2 on that coordinate. And the 1, same thing. So all we have to do here, look at this. I'll just highlight it. I'll just choose this as my 2's. So what we have going on, my party people, is going to be my y is going to be 6. My x is going to be 7. Write the subtraction symbol out for both. And then we'll choose this one for the 1's, the x1 and y1. Be careful about that negative right there, my party people. So we have -2. So that would end up being, again, -2 up top. Notice the double negative. And then on the denominator, we have 3.5 for the x. So that'll be 3.5 right there. Nice and easy, nice and simple. Now what we'll do is we'll clean this up a little bit. So we have 6 minus -2. So that's going to be +2. 6 plus 2 is 8. Then we have 7 minus 3.5. Well, that's the same as 70 minus 35. 7 is double 3.5. So if you take away half of yourself, you have that half left. 7 minus 3.5 is 3.5. If you need to see that, something like this will help you out. So we have 8 over 3.5. What's the answer going to be? Let's check our answer choices. And don't get fooled. Don't get fooled. We have 3.5 divided by 8 right there. That is not the answer. It's 8 over 3.5, not 3.5 over 8. So it looks like our answers are going to be whole numbers either here or here. Well, my party people, if I want to get rid of that decimal, all I'm going to do is multiply by 2 on the top and the bottom, because the way to clear a half out is to double it. So 8 times 2, that'll be 16. What's double 3.5? What did we say earlier? That's 7. So we have ourselves 16 over 7 as that final answer. And booyah, my party people, there it is. I hope you're having fun so far. Answer is B. And question number 15, my party people. So if you're looking to learn how to solve more equations like this is for sure still a linear equation. It's just getting crazy long, right? So if you want to learn those advanced linear equations, I got you. Question number 15. This is going to be found in your math knowledge course, unit number 3. It's also going to be found at the end of your math basics course, and you can see some of it in arithmetic reasoning as well. I got you. But long story short, my party people, let's go ahead and party. So let's solve for x. How do we do this? Well, notice that we have a ton of parentheses. How do we take care of that, that, and that? Well, what's that word that starts with a D? Distribution, my party people. Let's go ahead and distribute here. The 4 goes to 2x and the -3. So 4 times 2x will be 8x. 4 times -3 will be -12. Next up, we have over here, let's go ahead and use purple for this. We have -3 multiplied by x and -3 multiplied by 5. Yes, you have to bring the sign with you. So we have -3 times x, that's -3x. -3 times 5 will be -15. So far, so good, my party people. And then up next, here's what we've got. Up next, we are going to take a look at the 5x. That's just going to stay right there where it is. There's nothing going on with it, so just leave it. And then we have the -2 being distributed with the 3x and -1. So -2 multiplied by 3x, that's going to be -6x. And then -2 multiplied by -1 is a +2. Again, just be careful with it. All we had to do first was clean things up. And we're still cleaning things up right now as we speak, because we still have to combine like terms. So we notice that we have 8x and -3x on the same side. Again, you can't combine across the equal sign. So we have 8x minus 3x is going to be 5x. And then we also have over here -12, -15. So that's going to be -27. On the right side, what do we have? So we have 5x minus 6x, and that would be -x. And then we have +2. All right. Look at this. Take a moment to just take this in. This is a little easier than before, right? A little more manageable than before. Now what we'll do is we're going to go ahead and move the x's over to the same side. I'll begin by just adding x to both sides. And once I do that, we see that that'll cancel out on the right side, giving us 5x plus x, which is 6 of those x's now. And then don't forget to bring that -27 and that 2 over there. And now what I'll do is I'll add 27 to both sides. Once that's done, my party people, we see the cancellation on the left, and we have 6x equals 29. Booyah, there it is. Last step, divide that 6 and we're done. Again, we turned something that looked really complicated into something that's actually very, very doable. So again, last step here will be to divide by 6 on both sides. And so we have 29 over 6. Do we need to figure out what that is? Let's just check the answer choices. Nope, those are all going to be in fraction form. So we are good. 29 over 6, and we are set. And here we are, our final question, my ASVAB party people. So we have x to the power of 5 multiplied by x to the power of 3. How do we get that done? Well, this is one of those questions that, hey, this is super easy if you know the terminology, if you know what's going on. Here we are multiplying powers. What's the rule for multiplying powers? We just add those exponents. X to the power of 5 multiplied by x to the power of 3. That's just going to be x to the power of 8. That's what you do when you have multiplication of powers. You just add those exponents. If you need a brief explanation of why that works, well, x to the power of 5 is 5 x's multiplied together. X to the power of 3 is 3 x's multiplied together. How many x's are being multiplied together? 8. So the shorthand way to write that is x to the power of 8. And that's why C, x to the power of 8, is the correct answer.